I had a question in an email. What are we supposed to do about our mechanism journal? We need journal entries. Journal entries for every chapter 7 and 6 mechanism. We did the first few together during class, but if you're still unclear about what to put in your journal, please go to the textbook, copy every shadow box you find and by hand with a title that is the section for that mechanism, and do them on paper and submit them to the mechanism journal submission area, which does not yet exist, but it will. It will be in the test 3 materials area where we do all of our test 3 things. And this is going to be 5 out of 5 points if you just copy the shadow boxes where the mechanisms are with the curved arrows. It's the easiest 5% in this course. It just involves you copying. That is the first step in learning mechanisms, copying a good mechanism out. And then doing it over and over is how you learn them, but that's up to you. So you're going to have that done before Monday, before you take the test Monday. It's due before you take the test. It's not after you take the test. If you're just starting mechanisms after the test, that's not how it works. That's not good for you. So that's what you're doing for your journal. This target molecule has a cis alkene in it. Your second target molecule will have either a cis alkene or a trans. And in a trans version of the same molecule, you'd have this CH2 up instead of down. And we're supposed to know how to make that one as well. So remember that the cis alkene comes from an internal alkyne with exactly the same number of carbons. And please, even in the previous example, make sure the first molecule you draw here has exactly the same number of carbons as the molecule here. This is where students throw away points. They'll add another CH2 right in here or another C over here, and you don't give me the right molecule, I can't give you points. So I'm going to make sure I have every carbon here down here, but it will be an alkyne instead of an alkene. So how many carbons on the left? 1, 2, 3, 4 more. 1, 2, 3, 4 more. How many on the right? 1, 2, 3, 4 with a methyl here and this stereocenter. 1, 2, 3, 4 with a methyl on the second one. Make sure the stereocenter didn't change. That's not what's happening here. It used to be R and it's still R. Good. We know how to make cis alkenes from internal alkynes. That's what that says. And get my pink going here. And now it's time for synthesis. I'll be using that guy later. You can pick either side where you said, when I made this bond, or I made this bond. It does not matter. You pick one. If you choose the one on the right, you'll have to draw that group less times. That's somewhat logical, I guess. I don't know. And you've got this, and you got to remember in the synthesis, that has to be an anion. So it's an acetylide. It's a butyl acetylide because it's got a butyl on the left. And the carbon here has to have a halogen on it. Please use chlorine when your useful reaction gave you the method of putting a chlorine on that carbon, CH2C methyl. And that the stereocenter is not involved in making this chloride. That's not a stereocenter. You don't have to worry about this changing at all in this synthesis. And we got this guy over here. And this guy over here, it's two new retrosynthesis problems. How do you make this? It came from its conjugate acid. We know how to make acetylides from acetylenes. And then we know how to make alkyl chlorides from alcohols because the instructor told us how at the top of the previous page. On the exam, it'll be the same page. All right, and that's on my list of saturated alcohols with 5 carbons or less. That's a acceptable endpoint. This is not acetylene. This is not an alcohol with 5 carbons or less. You have to show me how to synthesize that. Well, I also know how to make the bond on the left side. One at a time, please. You can't make both bonds at the same time. Remember, the C-triple-C had to be an anion, and the other carbon had to have what attached at the end? A halogen. And where does the acetylide come from? This is just the same as the previous example. It came from acetylene. And where did the alkyl chloride come from? Same as the previous example and this example. Where did this alkyl chloride come from? From an alcohol. And that's circled. Alcohol, 4 carbons. Acetylene made acetylide, circle. Start your synthesis. I'm going to shrink it down.
Doctor?
Yes.
Sorry to interrupt, but do we have to switch the stereocenters on the chlorine one when we
This is the carbon. This is the carbon that gets attacked. That is not a stereocenter. There will be no switching of stereocenters. That is not a stereocenter.
Oh, okay.
So in my previous example, that was the carbon that got attacked. So there was flipping, and it happened twice because there's a flip in this step and a flip making it too. But that's not a stereocenter. So yours will probably have a stereocenter involved being flipped in one of them and not in the other. How's that? How's that for a big tip? And then we're going to take this molecule here and make it into this molecule here. And then we're going to take this molecule here and make it into this molecule here. And then we're going to react them together. We can use our parentheses this time. You're getting no points for this. You're just copying your own molecules here. But you would get a point for saying when those meet, they make this. I'm going to draw it. 1, 2, 3, 4, C-triple-C. All right, so if you use the same base all day, I don't mind. KH. This one's PCl5 from the useful reaction. They meet to make this. That has to become what in the next step? This needs to become this. How do we do that? Same way we did before. KH is a good base to do this, and it's nice. It's got a short name and everything. That is a rather large anion, yes. Oh, lost both. Anion. There. You're now here. But you don't have anything to react that with yet. You need to this to become this. So let's see if this all comes in one. It does not. All right. Yeah. OH, CH2C. Give me the arrow too. Arrows are erasable. PCl5 replaces OH with a Cl. If this was a stereocenter, it would have been flipped. It is not a stereocenter. It does not change at all. CH2 is CH2. Now I got to combine these two things to make this wonderful internal alkyne. 1, 2, 3, 4, methyl. That is a big wedge. And 1, 2, 3, 4. That is this piece here, which now needs to become a cis alkene. You've got options. Please choose one. I will use BH3 and HOAC, and that will take you to your target. You could have used H2, comma, LINDLAR's cat, or you could have written the Lindlar's catalyst out fully if you're concerned about your spelling of people's names. Those are your choices, comma, comma. There we go. And that gives us our target molecule and a lot of points, 14, not to be laughed at. So do we have any questions about that? That's as small as I can get it. There we go. Okay. So if there's no objections, we're going to call it a day, and we will see you Monday for our test. Please make sure you've signed up for the proper section that you want to take the test, the 11 o'clock or the 5:30. It's a Monday test this time. Your problem set is due Friday at 11 p.m. I'm told that it's not quite as long as the other ones, and maybe not quite as difficult. I hope that's true, but you won't know until you start. So please get started. Don't do it last minute. Take advantage of the extra time to finish it. All right. So I will see you guys Monday.